Hey guys, before we get started with 16.3, let's do a little bit of a review. So last week we talked about angles. We talked about 4 different angles. We had this angle right here. We had an angle like this, an angle like this, and an angle like this. So what we're going to do right now is we're going to take a look at them and try to remember what these angles were called. Let's look at the one I circled in yellow. Think about it. Can you remember what that angle was called? It has that perfect little square right there in the corner. Which, yes, you're right. That means it's a right angle. Okay, and a right angle is always 90 degrees. That's what it measures. And a right angle forms that perfect little square there in the corner. All right, let's take a look at the one I circled in green. Well, to me, that angle looks like it's smaller than a right angle. So that means it's smaller than 90 degrees. And what was that called? Yes, that's right. It was called an acute angle. How many of you remember our little song for acute angles? Go ahead, sing it. Come on, don't be afraid. Sing it. Acute. So tiny, smaller than 90. Acute. So tiny, smaller than 90. So again, an acute angle is an angle that is between 1 degree and 89 degrees, smaller than a right angle. Then we have our angle over in the middle that's circled with the pink highlighter, and that one is larger than a right angle. Does anyone remember what that angle is called? Yeah, that's right, obtuse. I remember we just said it in that voice to make it sound like a big angle, obtuse angle. So right now we have our right angle, 90 degrees, our obtuse angle, which is greater than 90 degrees. So it's anywhere between 91 degrees and 179 degrees. And then we have our acute angle, which is smaller than a right angle. Anywhere between 89 degrees all the way down to 1 degree. And then our last angle down here on the bottom, circled with our nice bluish color. And do you remember what that angle is called? Yes, that's right, a straight angle. Very self-explanatory, being that it is a straight line. A straight angle. And do you remember how many degrees a straight angle is? Good, 180 degrees. All right, so we have our 4 angles today that we are going to refer back to at some points while talking about quadrilaterals. But before we go, I want to review one more thing. Okay, let's review the different kinds of lines we learned about. We learned about 3 different types of lines. The first one was, let's see, we had this and this. Does anyone remember what those lines were called? Remember, those lines are an equal distance apart. They're never, ever, 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 ever going to cross or intersect at any point. Yes, that's right. Those were called parallel lines. P-A-R-A-L-L-E-L. And what do we remember about, or what do we notice about the word parallel that kind of helped us to connect those lines to the word parallel? Yes, right in the word parallel, there are a pair of parallel lines. The L's actually make parallel lines. Let's see, use this highlighter here to show it. Right there, we have parallel lines in parallel. Okay, now let's take a look down here. What do we notice about those 2 lines? Yeah, we notice that they're intersecting and crossing one another, right? So yes, that was what we called intersecting lines. Now, remember we said that this other line up here is also an intersecting line. right? This is also an intersecting line, but it was a special kind of intersecting lines because not only are the lines intersecting, but where they intersect, they are forming, what are they forming? Yes, right angles. So when intersecting lines form right angles, those are actually called perpendicular lines. They are called perpendicular lines. Sorry. I'll probably get better at this as, the days go on. But that is called a perpendicular line because when they cross and intersect, they form perfect right angles. Do you see the perfect right angles there? Look right here in this corner, we have a perfect right angle. We have a perfect right angle here in that corner. We have a perfect right angle here in that corner, and a perfect right angle here in that corner. So that's what makes those intersecting lines perpendicular. Whereas when I look at the ones that I circled in green, those do not form right angles. So they're just plain old intersecting lines. Okay, so what I'm going to have you do now is I'm going to tell you the pages that you need to rip out. We are going to be working today on, let me see, 16.3, and from your big book, you're going to need to rip out 593 and 595. From your skinny book, you're going to need to rip out page 201. Okay, so what you need to do right now is you need to pause this video and you need to go into your math book and you need to rip these pages out. You also need to make sure you have a pencil ready. Okay, so pause the video and get your materials together. Okay, so now that you're ready with all your papers ripped out, let's start just like we do in class and begin with our solve and share. I want you to take a couple of minutes to try and figure out the solve and share.
Draw 3 different four-sided shapes that have opposite sides parallel. Explain how your shapes are alike and how they are different. Solve this problem any way you choose.
Okay, so give yourself a couple of minutes and see if you can draw 3 different four-sided shapes that have opposite sides parallel. Think, remember, let's go back real quick to our lines. And remember, this is what parallel lines looked like. Parallel lines were the ones that were circled in yellow, where they're never, ever, ever going to cross each other. So you are going to draw 3 different four-sided shapes that have opposite sides parallel. And then explain how your shapes are alike and how they are different. Okay, take some time to do this. Okay, so does your paper look something like this? I mean, there are, of course, different variations of what you could have drawn, but here is just one sample. So right here, I have drawn 3 different four-sided shapes that have opposite sides parallel. So if I'm looking now, I look at my red figure, which is a rectangle, and I have opposite sides are parallel. This side is parallel with this side. Do you agree? Yes. Then we also have this side is parallel with this side, right? So I have 2 pairs of parallel sides in my rectangle. I also drew another figure in blue. Does anyone know what that figure is called? Yes, a trapezoid. So my trapezoid has my top and my bottom are parallel with one another. Are my other sides parallel? Are those sides parallel? No, right. Why? Yeah, because if these lines continue going, they will eventually cross each other. So they cannot be parallel. And the last shape I drew in green is does anyone know what that shape is called? The special name for that is a parallelogram. Okay, so a parallelogram has these sides are parallel, and then these sides are parallel. So now, how are these shapes alike and how are the shapes different? Well, one way that they're all alike is they all have at least one pair of parallel sides. They all have four sides. They all actually have four angles as well, right? In the corners here are our angles. So each one of these figures has four angles. Okay, you see that? So those are different ways that they are alike. Some ways that they are different is if I look at this figure right here, my rectangle, when I look at those angles, I notice that those are actually right angles. So a rectangle has four right angles, which that makes it different than my other two figures. When I look at my trapezoid here in the center, I notice that, oh, this figure is different than the others because this one actually only has one pair of parallel sides, whereas my other two figures have two pairs of parallel sides. And if I'm talking about my angles here, I notice that my bottom two angles are acute angles, whereas my top two angles are obtuse angles. And again, sometimes it's hard to look at the angles, but what's great is when we have a piece of paper in front of us, we can take that piece of paper and we can turn it upside down. We could turn it sideways, and we can look at these angles from different views to really see that angle and try to figure out, is it a right angle? Is it an acute angle? Is it an obtuse angle? And now last, I have my parallelogram over here. So in my parallelogram, I notice that I have two pairs of parallel sides, but also it's different than my rectangle because there are two acute angles and two obtuse angles. Okay, so I hope yours kind of looks similar to this. The look back on the bottom of your page was for you to just jot down the things that they have in common, and that was your space to write that. Okay, let's go on to some visual learning. So flip your page over, and now you're going to be looking at page 594 because this is going to go with the solve and share. Okay, ready, set, go. Not solve and share, sorry, visual learning.
Quadrilaterals have properties that make them different from one another. How can you classify quadrilaterals? Think about this question during the lesson. A quadrilateral is a polygon with four sides. Quadrilaterals can be classified by their angles or the line segments that make their sides. Which of the quadrilaterals shown have only one pair of parallel sides? Which have two pairs of parallel sides? A parallelogram has two pairs of parallel sides. This quadrilateral is a rectangle. What type of angle does a rectangle have?
Select your answer.
Okay, so think about it. In your mind, tell me which one to select. What kind of angles does a rectangle have? Is it obtuse? Is it acute? No, it is right angles.
A rectangle has four right angles. Why can a rectangle also be called a parallelogram? A rectangle is also a parallelogram because it has two pairs of parallel sides. A square has four right angles and all sides are the same length. Why can a square also be called a parallelogram? A square is also a parallelogram because it has two pairs of parallel sides. Why can a square also be named a rectangle? A square is also a rectangle because it has four right angles. A rhombus is a quadrilateral that has opposite sides that are parallel, and all of its sides are the same length. A square is also a rhombus because it is a quadrilateral with opposite sides that are parallel, and all of its sides are the same length. A rhombus is also a parallelogram because it has two pairs of parallel sides. This quadrilateral is a trapezoid. A trapezoid is a quadrilateral with only one pair of parallel sides. Parallelograms, rectangles, squares, and rhombuses all have two pairs of parallel sides. Now you know how to classify quadrilaterals.
All right, let's look down to the bottom of the page where it says convince me. How are a parallelogram and a rectangle the same? How are they different? So look back up to the top and let's see, how are a parallelogram and a rectangle the same? Think about it. Here they are right here at the top. Okay, so what do you think? Yeah, that's right. They both have two pairs of parallel sides. So let's jot that down. They both have two pairs of parallel sides. So that's a way that they are alike. They both have two pairs of parallel sides. A rectangle is actually a special type of parallelogram. Now, how are they different? So what's a way that the parallelogram and the rectangle are different? Look at those two figures and think about, what's different? Who thinks they know? Yeah, that's right. A rectangle has four right angles, whereas a parallelogram does not have any right angles. So that's a way that they are different. They are different because a rectangle has four right angles. All right, that's right. So they're both alike because they have two pairs of parallel sides, but they're different because a rectangle has four right angles and a parallelogram does not have any right angles. All right, pause the video so that you can get this written down on your paper. Okay, so let's talk about this. I know it's super weird and confusing when we say, well, you know, a square is also a parallelogram, and a rectangle and a rhombus, and a rectangle is actually also a parallelogram. So here's how I try to think about it. I look at parallelogram. Parallelogram says it has two pairs of parallel sides. So any of these other figures that also have two pairs of parallel sides can be considered a parallelogram. So a rectangle has two pairs of parallel sides. A square has two pairs of parallel sides, and a rhombus has two pairs of parallel sides. So that means they can also be considered a parallelogram. For a rectangle has four right angles. What other figures up there also have four right angles? Yeah, a square. So you could say a square is also a rectangle. But you can't say that about parallelogram, rhombus, or trapezoid because they don't have four right angles. Now, a square can also be a rhombus because look at a rhombus. A rhombus says that it has opposite sides parallel, which check, a square has that, and all the sides the same length. A square also has that. So a square can be considered a rhombus. Now, nothing can be considered a square. Only a square is a square because a square has four right angles. The only other figure up there that has four right angles is a rectangle. But the other special thing about a square is that all the sides are the same length, and a rectangle does not have all sides of the same length. Okay? Now, as for a trapezoid, do you think a trapezoid can ever have right angles? Think about that for a minute. You know, what makes a trapezoid a trapezoid? Well, a trapezoid is a figure that has four sides and only one pair of parallel sides, which the trapezoid that we're used to seeing that looks like that little red pattern block that we've used since kindergarten is right here on the page. But that one doesn't have right angles, so could a trapezoid ever have right angles? Well, let's think about this. If a trapezoid only needs to be a figure that has four sides and one set of parallel sides, let's look at this figure right here. What if I were to draw something like this? Well, first let's look. Does this have right angles? It sure does. I mean, obviously my picture is not perfectly drawn, but I have a right angle right in there, correct? And then I have a right angle right in there. So this figure has two right angles. But let's see if it matches the other qualifications for a trapezoid. Does it have four sides? Oh, it sure does. Does it have one pair of parallel sides? Well, let's look and see. You know what? It does. This side down here on the bottom is parallel with this side here on the top. So a trapezoid doesn't always have to look like the traditional trapezoid we are used to seeing. This figure right here is also classified as a trapezoid. So trapezoids can indeed have right angles, which we notice right in those two corners. Okay, let's take a look now at page 595. And another example at the top, we just discussed that, about how a trapezoid can have right angles, and those opposite sides actually do form perpendicular lines. So if you look right here, this side here, nope, it's not working. This side here is actually perpendicular. Ooh, man, that didn't come out so great. Let's rewind that a little bit. Okay, this side here is perpendicular with this side because when those two lines cross and intersect, they form right angles. Whereas this line is also perpendicular with this line here. So a trapezoid can have perpendicular sides. Okay, let's look at guided practice and let's walk through it together. Number one, what is true about all quadrilaterals? Remember, you need to pause the video so you have time to write your response. So please just pause anytime you need. So what's true about all quadrilaterals? What did you guys write? What do you think? Yeah, you know what? I also agree. They all have four sides. And for what? Not only do they have four sides, but they also have four, yes, angles. They have four sides and four angles. Okay, so that is what makes a quadrilateral a quadrilateral. The word quad in the beginning of the word quadrilateral means four. Quadrilateral, four angles. Okay. Now, number two, what is the difference between a square and a rhombus? All right, let's flip back and look at this page. Let's look again at the classification of a square and a rhombus. Well, a square has four right angles and all sides are the same length. A rhombus has opposite sides parallel and all of its sides are the same length. So what is the same and what is different about those two figures, right? So think about that. What's the difference between a square and a rhombus? That's right. The main difference between a square and a rhombus is that a square always has four right angles. A square always has four right angles. So a square must always have 4 right angles. So even though a rhombus and a square are alike because they have 4 sides of the same length, they both have 2 pairs of parallel sides, and that's it. And the difference is that the square has the 4 right angles. All right, let's look at number 3. Now again, reading a question carefully is super important. Shane drew a quadrilateral with at least 2 right angles and at least 1 pair of parallel sides. Name 3 quadrilaterals Shane could have drawn. So again, does this mean that there can only be 2 right angles? No, because it says with at least 2 right angles. So there must be 2 right angles, but there could be 2, 3, or 4. Now, of course, I didn't say more than 4 because I know a quadrilateral only has 4 angles. And at least 1 pair of parallel sides. Does that mean it can have 2 pairs of parallel sides? No, it doesn't mean that. So there has to just be at least 1 pair of parallel sides. So something you could do right now is go back to your page with all of the different quadrilaterals and check them out and see which ones could have possibly been drawn. Also, maybe use your math notebook and draw some quadrilaterals and see if you can draw quadrilaterals that fit these descriptions. Again, remember to pause the video so that you can figure this out. All right, so did you say a rectangle as one of your figures? You would be correct, because when I think about a rectangle, does a rectangle have at least 2 right angles? Yeah, it does. Does a rectangle have at least 1 pair of parallel sides? Yes, it does. Let's look at a picture here. So a rectangle has at least 2 right angles. 1, 2. And a rectangle has at least 1 pair of parallel sides. Those sides are parallel. All right, as for another figure, did you say a square? If you did, you are correct. So a square, let's take a look at a square. A square also has at least 2 right angles, and a square also has at least 1 pair of parallel sides. Now, Now let's see. They want us to draw 3. So now I need something else that has at least 2 right angles and 1 pair of parallel sides. How many people were confused at this point? Because they just looked back at that first sheet and could not figure out which the other shape was. Okay, that's okay. How many people said, oh, you're not going to trick me, it's a trapezoid? Well, you would be correct. But again, it's not a trapezoid drawn as the traditional way we remember seeing a trapezoid drawn. In order for a trapezoid to have at least 2 right angles, it must be drawn like this. 1 right angle, another right angle. And again, my opposite sides there are parallel. So those were your 3 figures that Shane drew: a rectangle, a square, and a trapezoid. Okay, so for now, numbers 4 through 7, I want you to pause the video and I want you to try and write all the names possible for each quadrilateral. Writing one name is going to be super easy because we know their traditional names, but remember, different shapes can also be considered different figures. So take a minute and try to write down as many as you can, and then we'll go over it. So as soon as you're done, resume play on. All right, so let's check these out. Number 4, we can call this a quadrilateral. Because, well, that didn't type. That's weird. So we can refer to any four-sided figure as a quadrilateral. That's a name for any four-sided figure. And then we have their special names. So this figure for number 4 is also called a rectangle. And did anyone think of another name for this figure? Yeah, we can also call it a parallelogram because remember what makes a parallelogram? A parallelogram is that it has two pairs of parallel sides. And this figure does have two pairs of parallel sides. So for number 4, it was quadrilateral, rectangle, and parallelogram. Let's check out number 5. Well, again, we know we can call this a quadrilateral. What else could we call number 5? Did anyone else come up with something else? Yeah, a parallelogram. What makes a parallelogram is that it has two pairs of parallel sides. Excuse me. Number 6. What could we call number 6? This is going to be a big one. All right. Yeah, we can refer to number 6 as a quadrilateral. We can call it a square. We can also refer to it as a parallelogram. Because remember, a parallelogram is something that has two pairs of parallel sides, and a square definitely has two pairs of parallel sides. We can also call it, a rectangle, because a rectangle has two pairs of parallel sides and 4 right angles, and a square has both of those. We can also refer to it as a rhombus, because a rhombus has 4 sides of equal length, and a square also has 4 sides of equal length. So a square just has so many different names. So sorry, it's so big. There we go. So for number 6, it could be a quadrilateral, a square, a parallelogram, a rectangle, or a rhombus. Number 7. Ooh, I wonder if anyone got tricked with this one, especially if you didn't realize we could have wrote the word quadrilateral down. You might have left this one blank. All right, so of course, obviously, we know we can call it a quadrilateral because it has 1, 2, 3, 4 sides. So it is a quadrilateral, but is it any of my other special quadrilaterals? Well, let's see. Could it be a parallelogram? Does it have 2 pairs of parallel sides? No, it doesn't. Does it have any parallel sides? No. So a rectangle, does it have 4 right angles? No. Square, does it have all sides the same length, right angles, 2 pairs of parallel sides? Nope. What about a rhombus? Does it have 4 sides equal? No. And a trapezoid, does it have 1 pair of parallel sides? No. So the only way we can name number 7 is by calling it a quadrilateral, which means it's a 4-sided figure. It's not one of our special quadrilaterals. All right, so what we're going to do now, for 8, 9, 10, and 11, you have to write all the names possible for each quadrilateral. So that's just like we did 5, 6, and 4, 5, 6, and 7. So you're going to do the same exact thing for 8, 9, 10, and 11. Now again, look at number 10. What shape is that? Turn your paper around, look at it from different angles. It is not a diamond. So make sure you're looking at that from different angles to see what shape they've actually drawn there. All right, so that's part of your classwork. Circle 8, 9, 10, and 11. Okay, and then flip it over and I'll tell you what you're going to do on the back. Okay, so on the back, you're going to circle number 12. You're going to circle number 13, and you're going to circle number 16 and 17. Does that mean that you can't do 14 and 15? No, of course not. You can definitely do everything. Okay, so that's going to be your independent classwork. Now, let's take a look at your homework page, which I don't have it right here now because I can't find it on the online math, but I'll work on that. So for the homework, which was page 201, which you should have ripped out already, you're going to do the entire front. The front is just like numbers 4 through 11 on our classwork, where you're going to write the names for the figures. 1 through 4, it wants you to write the most specific name for the quadrilateral. So the special name, rectangle, parallelogram, square, trapezoid, rhombus. And then for 5 through 7, it wants you to write all the possible names for each figure. Then on the back, you're going to do 8, circle 8, 9, circle 9, 10, circle 10, and circle 13. So for the homework, you're going to do the entire front, and then on the back, you're going to do 8, 9, 10, and 13. And again, does that mean you can't do 11 and 12? No, of course not. Go for it. If you want to do 11 and 12, you can. Also remember, if you want to do, some extra practice for math, you can go into your page, and I gave you, let me see, I opened up the visual learning so you could watch that again. I also opened up the Practice Buddy additional practice, and Practice Buddy independent practice problem solving. So those are 3 things that are opened up for 16.3 that if you have extra time, go for it. Go ahead and do some extra practice. If not, don't worry about it. All right, so I will see you guys tonight at our live Zoom session. Can't wait. See you later.